So now we're left to look at some of the patterns, and hopefully as you've been going along here, you've been thinking about some of these equations and the types of graphs that they have. But let's see what we can notice. First question we have is, will the parabola open up or down? So let's look at the ones that have opened up or down. So let's start with the up ones. Most of them are up, actually 3 out of the 5, so I guess that's the slight majority. So the ones that are opening up would be y equals x squared, y equals 2x squared minus 5x plus 4, and y equals x squared minus 3. The ones that are opening down are the other two. So the ones that are at the bottom here, we have the y equals negative 3x squared minus 6x minus 1, and y equals negative 1/2 x squared plus 3x minus 6. So can you notice what is different about the ones that are opening up, which was the first 3? We call those concave up. The U is facing up, kind of like just a regular cup, versus upside down, like you'd be flipping something upside down and all the stuff inside would fall out, which is the bottom 2. And so what we have in those situations is they will open up if the A value, if that first number, the A value, is positive. And they'll open down, notice in these last two, the ones that are directly above us here, if the A value is negative. So negative 3x squared and negative 0.5x squared. So if the A value is negative. So what we're filling in the other blanks here is that the parabola will have a minimum, so it will have a bottom, in other words. It'll have a minimum point or a bottom point when the A value is positive. So that's a little bit counterintuitive, but again, if it's concave up like this one right here, the A value is positive, which means it has a minimum value. Notice that's the lowest point on the graph. Versus if it's upside down, then it will have a maximum, kind of like a top value. So like, for instance, this one right here, since it's flipped upside down, there is a maximum value that it will reach. So that has to do with the first number in the standard form. If the A value is negative, then it's going to flip upside down. If the A value is positive, then it's going to be right side up. And you kind of have to keep track of where you might have a minimum and where you would have a maximum. The second thing that we're going to notice is, where is the parabola's y-intercept value? So looking at these different parabolas, I'm going to switch to a different color here. So we have y-intercept value. Let's take the first one that we had here. So y-intercept value in the y equals x squared equation is at 0. The y-intercept value of this green one is at 4. The y-intercept value of this one over here, the blue one, is negative 3. The y-intercept value of the orange one is negative 1. And the y-intercept value of the purple one, you can't really see on the graph. But if you've noticed a pattern with the others, you notice that the c value is always going to be the y-intercept. So 0 comma c. Remember, a y-intercept always has an x value of 0. But that c value is essentially that y-intercept in each one of our equations. So you know where, if you have that c value, you automatically know where the graph is going to cross the y-axis. The next thing is something called the axis of symmetry. Okay, so that's a very mathy sounding word or phrase. But an axis of symmetry, think about that word symmetry. Symmetry is like a dividing line where it is equal on both sides. And when you have a parabola, that axis of symmetry goes right down through the middle. So whether you have a minimum or whether you have a maximum, that parabola's axis of symmetry is going to go right down through that and divide it into two equal parts. So that line, that dotted line that I was just drawing over to the left here, is called the axis of symmetry. All right, and to find where that axis of symmetry is, there's actually a little formula that we use that involves both the A and the B values from the equation. Now, that formula looks like this. X equals negative B, the opposite of B, in other words, over 2 times the A value. That little formula right there will automatically tell you what the axis of symmetry will be. So it'll be an X equals equation because the axis of symmetry is a vertical line going up and down, and anytime you have a vertical line, your equation is X equals whatever the X value is for that point, all right, wherever it goes through the x-axis. So the axis of symmetry, by the way, will always go through that vertex point. So axis of symmetry goes through the vertex, all right, and we'll talk about vertex next, but basically that's the max or min point. That's the maximum or minimum on our graph. All right, so I kind of got a little bit ahead of myself there, I guess, but let's just switch colors again. And so where is the parabola's vertex? So again, the vertex has to do with the maximum or min point. This is our vertex right here. That's the max point of that parabola. This is our vertex, which is the minimum point of that particular parabola. So the vertex is just another word for the maximum or minimum point then, okay? So since parabolas are symmetrical, in other words, they're divided equally in half, the vertex will always lie somewhere on that axis of symmetry. So that axis of symmetry always goes through the vertex, and the vertex is always on that dividing line. So once you know where the axis of symmetry is, once we know this piece up here, we automatically then know the x value of the vertex. And then to get the y value of the vertex, so in other words, once we have that, we know the x value of our vertex point. And so to get the y value of our vertex point over here, we're going to have to plug that into the original equation and evaluate, like work through the order of operations to get y. So don't worry about that yet. We're going to practice that, but here are the different pieces that we're talking about. And finally, the last bit of the notes for today has to do with something called the roots or the zeros of the quadratic function. Now, the roots or the zeros are essentially just your x-intercepts, because the zeros is kind of like where is your y value 0 here? So it goes right through the x-axis. The x-intercept right here, in this case, will have something, it's a little bit hard to see exactly what the coordinates are there, but maybe something like 1.7 comma 0. And this one over here would be something like negative 1.7 comma 0. So the 1.7 and the negative 1.7 are called the zeros. Sometimes parabolas have zeros. Like this red parabola has 1 0, or 1 root, because it just crosses the x-axis once. But you'll notice some of these other parabolas don't have any zeros, like this one, because it never crosses the x-axis. Same thing is true for the green one up here. It never crosses the x-axis. So sometimes a quadratic function will have a 0 and sometimes it won't. But when it does, it's always going to be the x-intercepts. Okay, the roots or the zeros of the quadratic functions are always the x-intercepts. So sometimes a parabola can have two x-intercepts, like I talked about above. Sometimes it can have one x-intercept if its maximum or minimum point, like this one right here on the red parabola, is right at the x-axis. And sometimes if it never crosses the x-axis, then obviously it's not going to have any x-intercepts and therefore it won't have any zeros.